In 1874, the 13th year of the reign of Emperor Tongzhi in the Qing dynasty, Commander Wu Guangliang led an expedition to explore mountains and cultivate the wilderness. He inscribed "Cultivate the Wilderness" on a rock cliff, which now lies on the riverbank under the ChiChi Bridge. 100 years later, the Water Conservancy engineers upheld the forerunner's spirit of cultivating the wilderness and constructed a Legend of Water Resources project on the ChiChi River. ChiChi River, the longest river in Taiwan, measures 186.6 kilometers in length. ChiChi River originates from Sakuma Mountain, which is between the leading peak and the eastern peak of Hehuan Mountain at an altitude of 3,275 meters. Flowing down from the steep mountain valley, snaking through the uplands and merging with other streams, ChiChi River stretches out from the Bakwa Mountain Range and the hills in Dolio, forming alluvial fans, and ends up in Jianghua County between Dazhen, Mailiao, and Yunlin townships before flowing into the Taiwan Straits. The drainage area of ChiChi River is 3,156.9 square kilometers. The area of its alluvial fans is 1,800 square kilometers. As the geology of the upriver region is fragile black shale and sticky slate, the silt content of the river is quite high and the water is always murky. In addition, the river always runs wide and fast, which has contributed to a long history of water conservancy development effort dating back from the Qing dynasty through the time of the Japanese occupation and up to the present. The development of water resources of the ChiChi River can be divided into two parts. One is the upstream hydropower of the Sun Moon Lake system. The other is the agricultural irrigation of alluvial fans downstream. Time-wise, irrigation had grown into a certain level by the early Qing dynasty. Nevertheless, hydropower was not introduced until the Japanese occupation period. In the past, farmers living on the downstream shores of the river used bamboo, wood, stone, and earth to form simple water-diverting facilities, such as gabion, conical gabion, and weedstone dams to block and divert water for irrigation. However, there was a huge difference in river flow between wet and dry seasons. When the heavy storms came, the floodwater ran swift and concentrated. The makeshift diversion structures were constantly being damaged or washed away, and repairs took time away from farming. During dry seasons, flow reduced dramatically, and these occur at the time of the first rice planting. Often there is insufficient water for irrigation. Although they pumped groundwater to augment the supply, it was never enough to meet demand, and there was constant conflict over surface water distribution. Throughout its long history, the withdrawal of the rich groundwater beneath the alluvial fans have not been efficiently planned, resulting in a continuous decline in the groundwater table. Furthermore, the irreversible land subsidence along the coastal areas has had a serious negative impact on the environment. The mission of the ChiChi Common Diversion Project is to enhance irrigation water supply efficiency, improve the stability of water supply, increase the supply of surface water and to reduce the use of groundwater, and to resolve the long-standing issue of proper utilization of water resources along ChiChi River. As early as 1957, the Taiwan government conducted studies related to the ChiChi Common Diversion Project. However, due to a large project cost and issues related to the river sedimentation, the project had long been suspended from implementation. In 1989, the project was approved by the Executive Yuan, and the construction of the North Shore Water Conveying Tunnel began in October 1991. The ChiChi Common Diversion Project was officially underway. Due to considerations of developing an offshore industrial park in Yunlin County, on May 17, 1993, The Executive Yuan approved the inclusion of industrial water facilities from Linne to Mailiao in the ChiChi Common Diversion Project. At that time, the entire scope and content of the ChiChi Common Diversion Project was finally determined. This project was started in October 1991 and completed in 2001. During these 10 years, the status of the Water Resource Bureau of the Taiwan provincial government was upgraded and the organization was restructured. First, it was called the Water Resources Office, Taiwan Provincial Government. Then, Water Resources Office, Ministry of Economic Affairs. Eventually, in March 2002, it was renamed Water Conservancy Agency, Ministry of Economic Affairs. The project was executed by the Central Water Resources Bureau and the Fourth River Bureau. The Zhanghua and Yunlin irrigation associations helped to construct the expansion sections of the leading canals, while the county governments in Zhanghua, Yunlin, and Nantou provided immense assistance in land acquisition. The ChiChi Dam is located at the Linwei Gorge on the Choshui River, ChiChi, Nantou County. The weir is 352.5 meters in length, 15 meters in height. On the dam crest, there are 18 10-meter-high spillway gates. On both sides of the dam are 2 gates for discharging silt. In addition, a fish ladder was built on the left bank. During wet seasons, from June to September, 10 of the 18 gates are closed, while 8 gates on both sides are opened. The 2-meter-high regulating gates raise the water level for water intake. This meets the needs for water intake and flood release. On the other hand, during the dry season, from October to May, all 18 gates are closed, and the water level can be raised by 9.5 meters. This damming effect creates a strong storage capacity of 10.05 million cubic meters. The north side of the Diversion Dam neighbors the 100-year-old Cultivate the Wilderness stone tablet, which was written by Commander Wu Guangliang in the Qing Dynasty when he hewed out an ancient pass of 8 passages. The inscription, containing 4 bold and vivid words, Cultivate the Wilderness, has now been designated as a Level 1 National Historical Monument. To preserve the original appearance of the monument, proper measures were taken during the design and construction of the Diversion Dam. The Lung'an Canal, a county-level historical monument, also passes through the hills just south of the Diversion Dam. This monument, too, has been left intact after the construction of the Common Diversion Project. The north intake part of the appurtenant works of the dam has a design capacity of 70 cubic meters per second. The water is delivered to the Zhanghua Irrigation Association for irrigation of 40,000 hectares of land. Under planning is the Mingjian hydropower plant, which will make use of a drop of the canal for power generation. The south intake is designed to intake a flow of 90 cubic meters per second. In addition to the 60,000 hectares for the Yunlin Irrigation Association, the water also supplies the offshore industrial park and supplements the public water supply of Nantou and Yunlin counties. The maximum intake on both sides is expected to be 160 cubic meters per second, the highest capacity in Taiwan. In order to deal with the problems caused by silt, there are gigantic desilting basins on each bank at the downstream side of the weir. To keep the operation of silt discharge from affecting the water supply, the north desilting basin is designed with 2 units in parallel, while the south one is comprised of 3 subbasins. When one subbasin is in the process of discharging silt, the other can still supply water. Thus, water can be supplied continuously. The completion of the ChiChi Common Diversion Project directly improves the irrigation efficiency on both shores of the Choshui River. In the project, the leading canals, like 2 leading arteries in the human body, will shoulder the key function of conveying and allocating water of the Common Diversion Project. The length of the northern leading canal from the desilting basin on the north and to Shengang Canal No. 3, Dacheng, Zhanghua, is 51 kilometers. The first 23 kilometers connect the northern desilting basin with the intakes of Dongyuan Canal, Babao Canal, and Zizipi Canal. This is the so-called new section of the canal. The latter 28 kilometers start from the intake of Zizipi Canal, going west along the existing canal of the Irrigation Association, connecting Yongji Canal 2 and 3 with Shengang Canal 1, 2, and 3. This is the so-called expansion section. Upon the completion of the ChiChi Common Diversion project, the current intakes of irrigating canals on both banks of the Choshui River will be replaced by the intakes of the project. The function of the intake of Babao Canal in the north will be reduced markedly and become a standby intake. Mr. Lin was said to implement the method of rock gabions, aiding Mr. Shishibang in diverting water into the Babao Canal. People now can still visit the Temple of Mr. Lin in Ershui, Jianghua, built in his honor. The Jianghua Irrigation Association uses all of the water conveyed through the northern leading canals for irrigation. Near Mingqian Township, the drop in elevation of the canal is large. Therefore, plans call for the construction of a hydropower plant in this reach. In addition, to supplement irrigating water during the dry season in the uplands of Bagua Mountains, water will be piped and distributed to the area. This distribution project has been incorporated into the follow-up program of the ChiChi Common Diversion project. The south leading canal from the desilting basin to Inchi Canal, Shiluozhen, Yunlin, is around 38 kilometers in length. The first 15 kilometers from the desilting basin to the intake of Dolio Grand Canal is the so-called new section. At the end of the intake of Dolio Grand Canal, the leading canal runs into Qingshui Creek, meeting intake 1, 2, and 3 of the Zhougang Canal. Passing through the Linne Water Distributor and Jiangjiao Water Distributor of the Zhougang Canal, and then flows into the Luzhangke Canal, Shilo Branch, and Inchi Canal. This section spans 23 kilometers and is the so-called expansion section. On the path of the south leading canal going west, it runs through Dongpuna River, a tributary of Choshui River, and Qingshui Creek. The pipelines are buried beneath the creeks. Due to large flow rate, 2 large diameter pre-stressed concrete pipes are used. The pipes have a diameter of 4 meters, which is rare in Taiwan. The octagonal water distributor in Linne is the most outstanding facility of the south leading canal. Whether for use in the offshore industrial park, in Yunlin, in the Choshui power plant, or for irrigation along the Zhougang Canal, the Ma'yun branch, or the Wutu branch, all water is distributed here. Moreover, the water used for generating power in the plant will be released back to the Zhougang Canal. The Choshui Power Plant, located in Linne, Yunlin County, is a small hydropower station. Construction began in 1921, and the plant began to supply electricity in 1923, continuing to operate for 80 years. It is expected to be designated as a historical site. The facility for industrial water includes the 42-kilometer-long pipes ranging from Linne to Mailiao and a 20-hectare tailwater reservoir in the offshore industrial park. The offshore industrial park consists of the 4 districts, namely Mailiao, Taishi, Xinxing, and Sihu. At present, only the No. 6 naphtha cracker of Formosa Plastics Corporation is well established in the Mailiao district. When running at full capacity, the daily demand for water is 250,000 cubic meters. This industrial water pipeline is the first of its kind for industrial use in Taiwan and is distinguished from the general industrial water through potable water systems. Pre-stressed concrete pipes, which have good physical characteristics and are easy for construction, were utilized here. Double pipes were used with diameters of 1,750 and 2,000 millimeters, respectively, and the pipes were deployed along the overbank of Choshui River or on the embankment of the southern bank. Mailiao District, where the tailwater reservoir is situated, lies on the southern side of the mouth of ChiChi River. Formerly a beach, Mailiao came into being through landfill and ground enhancement by dynamic compaction. The tailwater reservoir is semi-underground. It has storage capacity of 800,000 cubic meters, enough to meet a full-day demand once the entire industrial park is completely developed. The completion of the Common Diversion project signals the arrival of a new era in water resources management. The ChiChi Diversion Dam is to become the hub for centralizing and distributing the water resources of ChiChi River. Containing 10.5 million cubic meters of water during dry seasons, it is set up to accurately possess water resources data throughout the entire drainage area and to efficiently manage and operate the resources. Furthermore, it is the establishment of a mechanism for coordination among government agencies. The ChiChi Diversion Dam is now managed and operated by the Central Water Resource Office, Water Resource Agency under the Ministry of Economic Affairs. Through the newly established ChiChi River Water Resources Management System, the office has access to comprehensive data on the status of the entire river basin. Using these data, the Water Resource Office can perform in-depth analysis and predictions to optimize the entire water resources management. Strategies being implemented to achieve integration in the management of water resources can be classified as follows: common diversion, centralized distribution, and integrated utilization. The common diversion objective was achieved at the completion of the ChiChi Diversion Dam. The fulfillment of centralized distribution relies on effective possession and analysis of supply-demand data by the Central Water Resource Office and coordination by government agencies. Integrated utilization of surface and groundwater is under the stage of obtaining and analyzing groundwater data. The achievement of this last goal in the future is expected to pose the biggest challenges to the integrated water resources management system. It took 10 years and 23.8 billion NT dollars to complete the ChiChi Common Diversion project. The scale of the project, its coordinated management procedures, and its emphasis on water resources conservation throughout the entire river basin will serve as a model for future water conservation projects in Taiwan. The achievement of the project has not only succeeded in extending the benefits of the river, but has also established a prototype for developing water resources of other basins in Taiwan.